Now next we will do the last question of exercise 7.1, which is question number 8. Okay, see what is question saying. In right triangle ABC, ABC is right angled at C. Okay, M is the midpoint of hypotenuse AB. AB is the hypotenuse as it is opposite to the right angle. Okay, so M is the midpoint of hypotenuse AB. C is joined further. C is joined to M, and M is produced to till point D, such that DM is equals to CM. Okay, this CM is equals to DM. Now point D is joined to point B. Okay, now what we have to prove? We have to prove that triangle AMC is congruent to triangle BMD, means this triangle is congruent to this triangle. Also angle DBC, means this angle is 90 degree. Next, triangle DBC means this triangle is congruent to triangle ACB, means this triangle ACB. Okay, last we have to prove that CM is half of AB. This CM is half of AB. Okay, now first of all we will write what is given in the question. Okay, we are given that triangle ABC, in triangle ABC angle C is 90 degree. Okay, M is the midpoint of AB. It means AM is equals to BM. Okay, because M is the midpoint of AB. Further, CM is equals to DM. It is also given. I have written here. Now, whatever we have to prove, I have written here triangle AMC congruent to triangle BMD, angle DBC 90 degree also we have to prove. Now, triangle DBC congruent to triangle ACB we have to prove. Next and at last, CM is half of AB. Okay. Now, see the first bit what we have to prove. Triangle AMC congruent to triangle BMD. In triangle AMC and triangle BMD, if you see, AM is equals to BM. Okay, and CM of this triangle is equals to DM of this triangle. Okay, means two sides. This side is equals to this side and this side is equals to this side. Two pair of sides we got equal if we get included angle of these two sides also equal. Then by side angle side congruence rule, the two triangles will be congruent. And clearly if you see the figure, we have angle AMC equals to angle BMD by vertically opposite angle. They are vertically opposite angles because DC and AB are intersecting at point M, so it will make a vertically opposite angle, and that too they are equal. Okay, now see in triangle AMC and BMD. AM is equals to BM because M was the midpoint of AB, it is given to us, and angle AMC is equals to angle BMD by vertically opposite angles, and CM is equals to DM. CM is equals to DM, this is given. So by side angle side and side angle side of congruence rule, these two triangles are congruent. Okay, BM was corresponding to AM. Okay, so A was corresponding to B, M was corresponding to M, and this C was corresponding to D. Okay, and according to the correspondence we have here triangle AMC and BMD, and they are congruent by SAS congruence rule. Next what we have to prove? We have to prove angle DBC 90 degree, means this angle 90 degree we have to prove. This angle is 90 degree we have to prove. How we can prove these two triangles 90 degree? See, if somehow we get DB parallel to AC. Okay, if we get DB parallel to AC, then sum of these two, if DB is parallel to AC, then BC will act as a transversal, and we know that sum of interior angles on the same side of transversal, if BC is the transversal, if BC is transversal and AC is parallel to BD, and BC acts as a transversal, then sum of interior angles on the same side of transversal will be 180 degree. If this is 90, so this angle we can get, because sum of this angle and this angle will be 180, and if this is 90, then this will be also 90 degree. Okay, now see, angle ACM, okay, angle ACM means this angle, and angle BDM, they are equal. Angle ACM and angle BDM, I have named here angle 1 and angle 2, they are equal. Why? Because triangle AMC and triangle BMD were congruent triangle, as we have proved above. Okay, so by CPCT, angle 1 is equals to angle 2, and angle 1 is what? Angle 1 is ACM, and angle 2 is what? Angle BDM. Okay, so angle ACM and BDM are equal, as they are corresponding parts of these two congruent triangles. Okay, also this angle 1 and angle 2 are alternate interior angles also, and they are equal. Okay, also angle ACM and angle BDM are alternate interior angles, and they are equal also. ACM and BDM are alternate interior angles, clearly we see, and they are equal also. So if two lines are there and two lines are getting intersected by one transversal, so that the alternate interior angles are equal, then the two lines which are intersected by the transversal, they will be parallel. This we have studied in chapter number 6. Okay, property of parallel lines and transversal. Okay, so BD and AC are intersected by the transversal DC such that alternate interior angles are equal. Hence, DB will be parallel to AC. Implies that DB is parallel to AC. Now we got DB parallel to AC. Okay, DB parallel to AC, and again if we see in this figure, DB is parallel to AC, and this BC is now acting as a transversal. This BC is a transversal, and we know that sum of interior angles on the same side of transversal is 180 degree. Okay, so if BD and AC are parallel lines, BC is a transversal, so angles on the same side of this transversal are angle ACB and angle DBC. So sum of DBC and sum of angle ACB, DBC is this angle and ACB is this angle. Their sum will be 180 degree because co-interior angles are 180. 180 I have written, supplementary it should be. Okay. Now DBC plus 90, because ACB is 90 degree, angle C is 90 degree. Okay. Their sum is 180. If we transpose this plus 90 to RHS, it will become minus 90. So 180 minus 90 is 90. Their difference is 90. So angle DBC is 90 degree, which is clear that angle DBC is a right angle. That only we were asked to prove. Okay. Further, see what we have to prove. Third bit. DBC is this triangle congruent to triangle ACB. ACB means this triangle. DBC congruent to ACB. Okay, now see, DB and AC are corresponding parts of these two triangles AMC and BMD, which we have proved in the first point. Okay, triangle AMC and triangle BMD. AMC and BMD are congruent, so DB will be equals to AC by CPCT. Okay, corresponding parts of these two congruent triangles. Also, further, okay, we are talking about triangle DBC and ACB. DBC and ACB. In DBC and ACB, DB was equals to AC. because they are corresponding parts of these small triangles, and DBC is equals to ACB. DBC is also right angle and ACB is also right angle. So these two angles are equal, and BC for this triangle, okay, and CB for this triangle. This BC and CB is common, okay, common side. So again, by side, this side is also equals to this side by CPCT, okay. So in triangle DBC and triangle ACB, DB is equals to AC by CPCT of these two triangles. This angle is 90 and this angle is 90. This was given and this we have proved, and BC for this triangle and CB for this triangle are common. So by side angle side and side angle side, congruence rule, triangle DBC is congruent to triangle ACB. Okay, third point also proved, third bit also proved. Now next, last one, CM is this, CM is half of AB, CM is half of AB we have to prove, okay. Clearly we can see that AB is part of this triangle ACB and DC is part of this triangle DBC. So clearly, if triangle DBC and triangle ACB are congruent, then AB will be equals to DC by CPCT. AB is equals to DC by CPCT. And we know that CM was equals to DM. Okay, so DC can be written as CM and CM plus DM. Also CM was equals to DM. Okay, we are given, see, this DC, this side DC, in place of DC we can write sum of DM and CM. Also DM was equals to CM. This is given in the question. Okay, so in place of DM I have written CM only, such that AB will we can get AB equals to 2 times of CM. Okay, 2 times of CM, because CM is equals to DM, no? So DC can be written as 2 times of CM. Let it be. Okay, so if we transpose this 2 is in multiplication with CM. So if we transpose this 2 to this side, LHS, we will get it like AB by 2. Okay, means half of AB. So CM is half of AB. Okay.